To produce steam, you need heat. Plant boilers rely on the process of combustion to generate this heat. To generate heat and produce steam efficiently, boilers need the proper combustion equipment, devices like burners and stokers. Safe and cost-effective steam production also requires careful control of the various boiler flow paths. For example, boiler operators need to monitor and control air, water, and steam flow. The main function of all burners is the same: to inject a mixture of fuel and air into the boiler's combustion area. Burners are used with fuels that mix easily with air, such as natural gas, oil, or pulverized coal. This burner, for example, is a typical gas burner. It uses dampers or registers to regulate the amount of air entering the burner. Pipes called spuds inject natural gas into the boiler. This is an impeller. It's basically a stationary plate with openings, or vanes, that cause the air to swirl around and thoroughly mix with the gas. An igniter starts the gas-air mixture burning. This one has a sparking device that uses electrical current to create a spark across a pair of electrodes. The spark ignites the gas-air mixture. As it burns, it provides heat for the boiler. Like all fuel burners, oil burners provide a means to mix fuel and air for combustion. But there are some important ways in which oil burners are unique. This shows the major parts of a typical oil burner. Dampers control airflow into the burner. This is an impeller. It's basically a stationary plate with openings or vanes that cause the air to swirl around and thoroughly mix with the oil. Since oil's a liquid, it has to be changed into a mist or atomized before it can mix well with air and burn. This example is a mechanical atomizer. Mechanical atomizers depend on the pressure of oil passing through a nozzle to produce a fine mist. Fuel entering the atomizer flows to a sprayer head. The oil is forced through the nozzle, which breaks the oil into droplets. The droplets are sprayed into the combustion area in the form of a fine mist. Here's a type of atomizer that can use either steam or air to atomize oil. Steam or air flows through a tube and then to a nozzle in the sprayer head. Oil is supplied through the atomizer to the sprayer head, which directs the oil into the path of the high-velocity steam or air. This breaks the oil into a fog-like mist as it enters the combustion area. This action makes the oil easier to ignite and burn. To start the oil mist burning, there's an igniter. This igniter consists of a sparking device and a separate atomizer which serves as a pilot for the burner. A small amount of oil is sent to the igniter atomizer. The oil flows through a nozzle, which creates the mist. The spark ignites the oil mist. After a flame is established at the igniter, oil flow to the main atomizer is started, producing an oil mist. Then the igniter flame ignites the oil mist, and the combustion process begins. Some boilers are designed to burn solid lumps of coal. A device that supplies and burns lumps of coal is called a stoker. Stokers can also burn wood chips or other solid fuels as well. This stoker has a series of grates to hold the coal. A drive mechanism moves the grates through the combustion area of the boiler. The coal is stored in a hopper. A gate controls the amount of coal fed to the grates. As the coal moves along, air is forced up through the grates to provide the oxygen needed for combustion. The burning coal moves through the boiler's combustion area and supplies the heat needed to produce steam in the tubes surrounding the combustion area. Coal ash falls off the grates into an ash bin. In this topic, we saw the major types of boiler combustion equipment. We looked at gas burners, oil burners, and stokers. Let's take a minute now to try some practice questions. This burner, for example, is a typical gas burner. It uses dampers or registers to regulate the amount of air entering the burner. Pipes called spuds inject natural gas into the boiler. The airflow into a boiler provides oxygen for combustion. Gases produced during combustion flow out of the boiler and are discharged from the stack. The flow of air and other gases through a boiler is referred to as draft. The components typically used to provide draft are fans. There are two basic categories of draft fans: forced draft fans and induced draft fans. As their name implies, forced draft fans force air into the boiler. A forced draft fan draws air from outside the boiler and forces it through the burner into the combustion area. Induced draft fans create draft by drawing combustion gases from the boiler. Many boilers operate with only a forced draft fan. However, some boilers need both types to provide the proper draft. For example, in this boiler, the forced draft fan supplies air to the burner. Then, the induced draft fan draws out the hot combustion gases. The demand for steam from a boiler is called boiler load or steam load. When boiler load increases, more fuel must be burned to produce more steam. When boiler load decreases, less fuel must be burned. Changes in boiler load also require changes in the airflow to the boiler. The mixture of fuel and air supplied to a boiler is called the fuel-to-air ratio. It's important to maintain the proper fuel-to-air ratio to avoid combustion problems. For example, if the boiler is not getting enough air, some of the fuel entering the boiler won't burn. Instead, it may get carried out with the combustion gases and wasted. In some cases, unburned fuel could build up in the boiler. This buildup could cause an explosion if the fuel were ignited. In oil-fired boilers, unburned fuel may create soot deposits that coat boiler tube surfaces. Soot buildup interferes with heat transfer and reduces the boiler's ability to produce steam. In extreme cases, you may also see black smoke coming from the stack of an oil-burning boiler that's not getting enough air. On the other hand, if a boiler gets too much air, some of the fuel is used up to heat the extra air. This heat flows out of the boiler with the combustion gases. As a result, there's less heat available to produce steam. Most boiler operating procedures specify the proper fuel-to-air ratio. In addition, many boiler control systems automatically adjust the fuel and air mixture as boiler load changes. In some boilers, the air supplied to the combustion area is preheated. Preheating the air raises its temperature closer to the point where ignition occurs. This, in turn, helps to ensure efficient and complete combustion. One way to heat the air flowing into a boiler is with a rotary air heater or preheater. This one consists of a series of heating surfaces or elements which are connected to a motor-driven shaft. The top half of this heater is in ductwork that routes hot combustion gases from the boiler through the air heater and on to the stack. The bottom half is in ductwork that directs incoming air through the heater and on to the boiler. A seal prevents hot combustion gases from mixing with the air flowing to the boiler. The heating surfaces rotate through the hot combustion gases. So, in this section, the heating surfaces are warmed by the hot gases. Then, the rotating heating surfaces transfer heat to the cooler air flowing to the boiler. The warmed air is sent to the boiler's combustion area. With this design, heat that would otherwise leave through the stack unused preheats the air entering the boiler, so the boiler operates more efficiently. The mixture of fuel and air supplied to a boiler is called the fuel-to-air ratio. It's important to maintain the proper fuel-to-air ratio to avoid combustion problems. For example, if the boiler is not getting enough air, some of the fuel entering the boiler won't burn. Instead, it may get carried out with the combustion gases and wasted. In some cases, unburned fuel could build up in the boiler. This buildup could cause an explosion if the fuel were ignited. One way to heat the air flowing into a boiler is with a rotary air heater or preheater. For a boiler to produce steam, water has to flow through the boiler properly. One way to provide water flow in a boiler is by a process called natural circulation. This simplified water tube boiler illustrates how it works. The boiler has two drums. The upper drum is sometimes called a steam drum. and the lower drum is often called a mud drum. There's also a series of water tubes called risers, which carry a steam-water mixture to the steam drum. And this one has a downcomer, which carries water from the steam drum to the mud drum. Boilers normally have several downcomers. In addition, there's a feed water inlet and a steam outlet. The water tubes in the lower drum are filled with water. The steam drum is only partially filled. There's enough space in the steam drum to allow steam to collect. As combustion occurs, the water tubes that surround the combustion area heat up. As heat is transferred to the water in these tubes, the water becomes less dense and lighter than the cooler water elsewhere in the boiler. Some of this water turns to steam. As a result, the heavier, cooler water flows downward into the lower drum, and the lighter steam-water mixture flows into the steam drum. Then, as the cooler water is heated, it too becomes lighter. It rises to the steam drum and is replaced by cooler, denser water. The steam flows to the plant through the steam outlet, and the water level is maintained by the water flowing through the feed water inlet. As long as combustion takes place, natural circulation continues. Not all water tube boilers rely on natural circulation. In some cases, a circulating water pump is used to produce the flow of water in a boiler. This type of circulation is called controlled or forced circulation. In this example, the pump draws water from the steam drum and forces it through the lower drum and the risers. As the water in the risers is heated, a steam-water mixture is produced. Water from the pump forces the steam-water mixture into the steam drum. If the pump circulates the water through the drums and the tubes, the boiler will operate as it's supposed to. Hypothetically, though, if the pump stops, the water will no longer circulate properly, and the boiler could boil dry and become damaged. To make sure there is proper water flow, most controlled circulation boilers use 2 or more pumps. So, even if one pump stops, the other pump will provide enough circulation to prevent damage to the tubes. With this type of water tube boiler, water circulation depends on the differences in density between water and steam. Mechanical devices, such as pumps, are not needed. This method of circulation is called natural circulation. One way in which boilers are made more efficient is by heating the feed water before it enters the boiler. If the feed water is preheated, the boiler will require less fuel to produce steam. A device that's used to preheat feed water is an economizer. Economizers are often used in water tube boilers. An economizer is basically a series of water tubes located in the flow path of the combustion gases. Feed water is routed through the tubes on its way to the steam drum. The water is heated by the hot combustion gases flowing past the tubes. The economizer improves boiler efficiency by making use of heat in the combustion gases that would otherwise be wasted. The steam produced by a boiler generally contains some moisture. Some plant processes require relatively dry steam, so the moisture could be a problem. To prevent equipment damage from moisture, some boilers are equipped with moisture separators, devices that remove moisture from steam before it's sent to the plant. One type of moisture separator is a centrifugal separator, or cyclone separator, located in the steam drum. It works by directing the steam-water mixture into a circular chamber. The circular shape of the chamber causes the mixture to swirl around. The swirling action creates a centrifugal force. This force flings moisture droplets against the chamber walls. Then the droplets run back into the drum. The lighter steam flows out the top of the chamber. Some boilers use a dryer along with centrifugal separators. This design is often found in processes where extremely dry steam is required. This dryer consists of a series of V-shaped plates. The steam flowing through them has to make several changes in direction. The water droplets can't change direction as easily as the steam, so most of the droplets separate and drip back into the drum. The steam flows through the dryer and onto the plant. One type of moisture separator is a centrifugal separator, or cyclone separator, located in the steam drum. It works by directing the steam-water mixture into a circular chamber. The circular shape of the chamber causes the mixture to swirl around. The swirling action creates a centrifugal force. This force flings moisture droplets against the chamber walls. Then the droplets run back into the drum. The lighter steam flows out the top of the chamber.